Factorising algebraic expressions. Up until now, we've been looking at expressions in factor forms, that is, they include brackets, and we've been trying to remove the brackets by expanding. Now, when we're factorising, we're doing the opposite process. So we have something in expanded form, and we're looking for common factors and highest common factors to write these expressions in factor form. So you can see here we have initially in factor form 5 times the expression x plus 3. Now we use the distributive law to expand the brackets and therefore write it as 5x plus 15. Now if I wanted to go from 5x plus 15 into factor form, so now I'm going back to what I originally have, how do I do it? Well, I need to look at these two terms and I need to look for a common factor, the highest common factor. So the highest common factor of 5x and 15 is 5 because it's a factor of both of those terms. Therefore, I take out the 5 and you can see that I can therefore write x plus 3 because 5 times x would give me 5x and 5 times 3 would give me 15. So essentially we're doing the opposite process compared to what we have just been doing. Just some key ideas which are worth noting. Throughout the chapter we will be factorising expressions by using highest common factors, and that highest common factor gets written in front of the brackets. Then we can also use some of the rules that we've already learnt. So for example, the difference of two squares rule can be actually used to factorise something. So remember before we were going for, if we saw something in the form a plus b times a minus b, we knew that we could write it as a squared minus b squared. So now we can do the opposite. If I see something in the form a squared minus b squared, then I'm able to factorise it in that type of form there. The same can be said with the perfect square rule. So again, we can reverse what we were doing before to factorise expressions. So if you see something that's written in this form a squared plus 2ab plus b squared, we can write it in the form a plus b all squared. So we'll work through some examples, and again I would like you to copy these examples into your exercise books as we work through them. Okay, so I have 3m plus 21. Remember, when we're factorising, we're trying to look for the highest common factor. So the highest common factor between 3m and 21 is going to be 3. And within the brackets, I'm going to have, what do I have to multiply 3 by to get 3m? I need to multiply it by m. Then plus, what do I need to multiply 3 by to get 21? It's 7. And you can always do a cross-check, because if I was to expand this using the distributive law, I would go 3 times m is 3m plus 3 times 7 is 21. A squared minus 4a, I'm looking for the highest common factor. The highest common factor between these two terms is a. A is representative in both of the terms. Therefore, a is going to be on the outside of my bracket. And what do I have to do? What do I have to multiply a by to get a squared? I need to multiply it by a. And what do I need to multiply a by to get minus 4a? I need to multiply it by minus 4. So you can see if I was to do the reverse process and I expand the brackets, a times a would give me a squared. Then a times minus 4 would give me minus 4a. Okay. We're moving on to example 2. I would like to factorise the following. So again, I need to look at my two terms and I need to look for the highest common factor. The highest common factor in these two terms is something that is common to each. So when I look at this term here, I can see that there is a p and an r. There's also a p and an r here. And then I need to look at my constants. I've got a 4 and a 2. So my highest common factor between these two terms here is going to be 2pr. Okay, because 2pr is a factor of both of those terms. So if I was to therefore write this in factorized form, what do I need to multiply this term here by to get this? I need to multiply it by q, plus what do I need to multiply 2pr by to get 4pr? I need to multiply it by 2. Okay, so you can see that the q and the 2, if I was to expand this out, we would get our original form. Okay, next I have 9m to the power of 3 times k minus 15mk squared. Again, I'm looking for my highest common factor. I can see that there's a k, which is a factor of both. I can see that m is a factor of both. And I know that 3 is a factor of both 15 and 9. So keeping this in mind, I know that a factor of each of these terms is going to be 3mk. That's the highest common factor of these terms. So what do I need to multiply 3mk by to give me 9m cubed? M to the power of 3 times k. I need to multiply it by m squared. Okay, if I multiply that by that, I would have to multiply it by 3m squared. If I multiply this by this, I'm going to need to get 9, and then m to the power of 3 times k. Then, since this is a minus, it's going to be minus. And what do I need to multiply 3mk by to get 15mk squared? Well, let's think about the constant. I'm going to have to multiply it by 5, because 3 times 5 is going to give me my 15. I've already got an m, and now what do I need to multiply k by to get a k squared? Another k. So, and you can always do a check. If I multiply this by this, I'll get 9 m to the power of 3k. Then if I multiply this by this, I'm going to get minus 15 mk squared. The final example for today's lesson is going to relate to grouping terms. So here I have x squared plus 3x plus 4xy plus 12y. Now, in each of these examples above, I was looking for a common factor to each term. So if I look at each of these 4 terms and I'm trying to find a common factor, I might start off by looking at each and thinking that x might be a common factor to each, but no, because this term does not have an x in it, so that doesn't work. And then there's no constant, which would be a common factor of each of the terms other than 1, but 1 is not going to be useful for us. So we have to use a different type of method to try and factorize this. So what we can do is we can group this. So we're kind of manipulating it in a way that we're then going to be able to factorize. So if I was to factorize this, I'm going to group my x squared plus 3x together. Now we've still got plus, and then I'm going to write the second part of this expression. Now, so I've kind of segregated the two from each other. Is there a common factor to both x squared and 3x? Yes, there is. X. And if I am to remove x from this as a common factor and then to factorize, I would have to get the x squared term, I'd have to multiply x by x. And then to get the 3x, I'd have to multiply by 3. Okay, you can see if I was to expand this, I'd have x times x is x squared, and then x times 3 is 3x. Plus, now look at these two terms. What's a common factor to each of these terms? Well, I know that 4y. Okay, there's 4y is in that term, and I could also factor 4y from this term. So 4y times x would give me that term, plus 4y times 3 would give me this term. Now, you might notice something. I've kind of done something that has now made each of these two terms have a common factor. Can you see that this has an x plus 3 in it? And this also has an x plus 3 in it. Therefore, I can take x plus 3 as the common factor. And then, if I was to multiply x plus 3. What would I have to multiply x plus 3 by to get this term here? I would have to multiply it by x plus, what do I need to multiply x plus 3 by to get this term? I would have to multiply it by 4y. And now you can see that I've fully factorized that initial expression, and if I was to use FOIL and expand the bracket, I would find myself back in that original expression.